Hi, this is Alex from devstories.eu. Microsoft Copilot Studio, episode 15 of 15. You spend weeks building custom plugins to let your agent query your internal databases and trigger actions. Then a new platform launches and you find yourself rewriting all those exact same integrations from scratch. The solution to this endless cycle of redundant work is the Model Context Protocol. The Model Context Protocol, or MCP, is an open standard that connects AI models to external data sources and tools. By adopting an open standard, you effectively future-proof your agents. You write the integration logic exactly once, host it on an MCP server, and any compatible AI client can instantly use it. Copilot Studio acts as one of these clients. Consider a scenario where your engineering team relies on 50 different internal diagnostic scripts and live file resources. You do not want to manually create and map 50 separate actions inside Copilot Studio. Instead, you configure your agent to connect directly to your proprietary internal MCP server. When the agent initializes, it asks the server what it can do. The server replies with a list of capabilities, immediately granting the agent access to all 50 engineering tools and live file resources. An MCP server exposes three main components to your agent. These are resources, tools, and prompts. Resources are read-only data sources. When your agent needs to check a live configuration file or a database record, the MCP server provides that data as a resource, loading it directly into the context of the model. Tools are executable functions. If the agent decides it needs to restart a virtual machine or update an engineering ticket, it calls the appropriate MCP tool and the external server executes the action. Prompts are predefined instruction templates provided by the server. They guide the agent on exactly how to format queries or interpret the data specific to that external system. Here is the key insight. People often assume that when you connect an MCP server, Copilot Studio imports and saves permanent copies of those tools into its own user interface. That is not how it works. The tools and resources are hosted completely externally. Copilot Studio dynamically reads what the server exposes at runtime. If your engineering team adds a 51st diagnostic tool or modifies the parameters of an existing script, they simply update the external MCP server. Copilot Studio automatically reflects those changes. You never have to log into the Studio interface to republish or update the action. Because the logic lives entirely on the server, you maintain a single source of truth for your organizational data and actions. The agent remains lightweight, functioning merely as the reasoning engine that decides when to communicate with the server. By separating your tools from the specific agent platform, you centralize your integrations and guarantee that your AI always has the latest capabilities regardless of which client interface you deploy. I highly encourage you to read the official documentation, try connecting an MCP server hands-on, or visit devstories.eu to suggest topics you want to see covered in a future series. That is all for this one. Thanks for listening, and keep building.